Hello, welcome everyone. My name is SID Achraf. I am a PhD student in Baji Mukhtar University in Nava. Today I have the pleasure to introduce my research topic about microstructural and structural properties of mechanically alloyed chromium-70 cobalt-30 powders. So our presentation will start with an abstract, then we will pass to some information about nanomaterials, mechanic alloying, and our system chromium cobalt. Then we will talk about our experience and discuss some results. So we will start now with the abstract. So nanostructured chromium-70 cobalt-30 material was prepared by mechanical alloying from pure chromium and cobalt powders in a planetary ball mill, rich PM 400 under argon atmosphere. So we get some morphological change, microstructural and structural variation. This variation was studied by scanning electron microscopy (MEB) and X-ray diffraction (XRD). Then the morphological observations shows the predominance of the fracturing phenomenon during the milling process because of the high hardness of both chromium and cobalt, which is evidenced by their low compressibility during the milling process. Now we jump to some information about nanomaterials. So, why do we choose nanomaterials? Nanostructure science and technology is a broad and interdisciplinary area of research and development activity that has been growing explosively worldwide in the past few years. Nanoscale materials are defined as a set of substances where at least one dimension is less than approximately 100 nanometers. Then, why do we choose nanomaterials? Because of their interest, because at this scale unique optical, magnetic, electrical and other properties emerge. These emergent properties have the potential for great impacts in electronics, medicine and other fields. Now we jump to talk about milling or mechanical alloying or ball milling. Milling in planetary mills is a simple and effective method to obtain nanostructured powders. The objective of milling is to reduce the particle size and the blending of particles in new phases. So milling gives us new phases and we go from micro to nanomaterials. So while milling, particles are rubbed with each other and with balls so that action creates energy. The energy transfer is governed by many parameters such as the type of mill, the powder supply to drive the milling chamber, milling speed, size and side distribution of the balls, and the type of milling, dry or wet, then finally the temperature of milling and the duration of milling. Now we pass to the picture. So we got here the movement of the supporting disc is going against the direction of rotation of the milling ball, so that creates friction between balls and particles. Now we pass to our system, chromium cobalt. Why did we choose cobalt chromium system? So cobalt chromium alloys are classified as predominantly base metal alloys and are widely known for their biomedical applications in the orthopedic and dental fields. In dentistry, cobalt chromium alloys are commonly used for the fabrication of metallic frameworks of removable partial dentures. Then, the increased worldwide interest is in utilizing chromium cobalt alloys for dental application is related to their low cost and adequate physico-mechanical properties. Finally, dental alloys on the basis of cobalt and chromium are one of the most preferred for production of metal frameworks of dental constructions because of their high strength, high corrosion and wear resistance, finally high biocompatibility. Now we pass to our experience. So we use in our experience a planetary mill pulverizer Rich PM 400 with a glove box Plus Labs ink with vials of 25 milliliters with number of balls 8 of 10 millimeter in diameter with a ball mass of 33 gram and the powder mass is 3 gram with a rotation speed 350 rpm with a stop time of 30 minutes per hour. We'll pass now to the conditions of characterizations. So we use for diffraction a diffractometer Broca D8 with a Bragg-Brentano geometry theta from theta to 2 theta with X-ray diffraction with copper radiation, as you can see here, with the 2 theta range from 10 degree to 130 degree with an angular pitch of 0.02 degree. The results are refined by mount program based on the Rietveld method combined to the Fourier analysis. Now we jump to some results. As we can see here, so XRD patterns of CrCO powders mixture for various time. So we notice appearance and disappearance of different peaks. That means a formation of new phases. And we notice a broadening of peaks. That means reduction of grains size with an increase of micro deformations. So we got various time here from 5 hours, 10 hours, 15 hours, 20 hours, 25 hours and 30 hours. So now we pass to the next. So we got here an XRD patterns chromium cobalt powders mixture for 0 hour. So as we can see, that is peaks of chromium in a plan 110 and 200 and 211 and 220. So there is some crystallographic information about chromium, as we can see, and cobalt. We got chromium with structure of basic cubic centered and cobalt with hexagonal closed pack. We have A for the chromium and A and C to the cobalt. Now we pass for next. So we noticed there is appearance of solid solution of cobalt in chromium with basic BCC structure and appearance of solid solution of chromium in cobalt with HCP structure with a small proportion of chromium that didn't react, as we can see here in the spectra shown in the photo. So we pass to the next. Now for 30 hour for milling, we notice presence of solid solution of cobalt and chromium and solid solution of chromium and cobalt with elemental BCC chrome and elemental HCP cobalt, as we can see here the peak are in the spectrum. So we pass now to see some references and we go to our conclusions. So we got formation of base cubic centered cobalt in chromium and chromium in cobalt HCP after 5 hours of milling. And we notice, and we got here a presence of solid solution BCC chromium cobalt in chromium and HCP chromium in cobalt and disappearance of elemental chromium and HCP cobalt after 30 hours of milling.